Hello dear student, myself Prof. Subburajke. Today we learn new topic, stationary wave. Firstly, we discuss how are stationary wave formed. Formation of a stationary wave. Consider a string stretched between two fixed points and the string is pulled at the middle and released. The releasing of string produces two progressive waves traveling in opposite direction. These waves are reflected at the fixed end. The wave produced in the string initially and their reflected wave combine to produce stationary wave. See this diagram. This is a stationary wave. Here alternate from antinodes. Here is nodes, antinodes and nodes. The formation of stationary wave on the string is shown this figure. The two-side arrow indicates the motion of the particle of the string. In this way, this is a stationary wave form. Then we discuss what is the definition of a stationary wave. Definition: when two identical wave traveling along the same path in a opposite direction interfere with each other and form loop, this resultant wave is called as a stationary wave. What do you mean by stationary wave? When two identical wave traveling along the same path in opposite direction interfere each other, the resultant wave is called stationary wave. Then we discuss next topic, an expression for equation of a stationary wave on a stretched string. Equation of a stationary wave on a stretched string. Consider two simple progressive wave, simple harmonic progressive wave of equal amplitude. Suppose this amplitude consider here A and wavelength consider lambda, propagating on long uniform string in a opposite direction. Direction is opposites. The equation of wave traveling along the x-axis in the positive direction is given by the equation of wave traveling along the x-axis in the positive direction is given by y1 is equal to a sine 2 pi into 2 pi nt minus x upon lambda. Consider equation first. Another equation, the equation of wave traveling along the x-axis in the negative direction is given by direction is negative, then equation of the wave is given by y2 is equal to a sine 2 pi nt. This minus sign replaced by plus here because direction is negative, hence nt plus x upon lambda. Consider equation second here. When these two waves interfere, the resultant displacement of particle of string is given by the principle of superposition of wave. We can write this y is equal to y1 plus y2. Consider equation third here. y is equal to y1 plus y2 because principle of a superposition of wave. Substituting equation first and equation second, in equation third we get here y is equal to a sin 2 pi nt minus x upon lambda plus a sin 2 pi nt plus x upon lambda. Adding this to equation, we know that by using trigonometry formula, sin c plus sin d is equal to 2 sin c plus d by 2 into cos c minus d by 2. According to this formula, we get y is equal to 2 a sin 2 pi nt 2 pi nt into cos 2 pi x upon lambda. Consider equation number 4 here. Then y is equal to twice a into cos 2 pi x upon lambda into sin 2 pi nt. Consider equation 5. Here rearranging equation 4, we get this equation. Substituting twice a cos 2 pi x upon lambda is equal to a. Then equation fifth become y is equal to a sin 2 pi nt because a is equal to what? Twice a cos 2 pi x upon lambda. Then y is equal to, we can write 2 pi n is equal to omega. Then y is equal to a sin omega t. Consider equation number 7. This equation number 7 gives the equation of stationary wave, which gives the resultant displacement due to two simple harmonic progressive wave. Okay, some question asked on this topic. Here first one, define stationary wave, and next one, derive an expression for equation of stationary wave on a stretched string. Then we discuss two conditions here, condition for nodes and another one condition for antinodes. Firstly, what is meant by nodes? Nodes are the point of minimum displacement. Means what? The point of medium which vibrates with a minimum amplitude are called nodes. Okay, this is possible if the amplitude is minimum. Here given condition, amplitude is minimum, that is capital A is equal to 0. Therefore we can write this twice a into cos 2 pi x upon lambda. A is equal to 0, we can write this. Okay, this cos 2 pi x upon lambda is equal to 0. Then we can find what is the value of 2 pi x upon lambda. This become 2 pi x upon lambda is equal to pi by 2, then 3 pi by 2, next 5 pi by 2. Take this value, then cos pi by 2, this becomes 0. Again cos 3 pi by 2, again 0. Next 2 pi x upon lambda is equal to 5 pi by 2, then cos 5 pi by 2, this becomes 0. And x become, this x is equal to lambda by 4, 3 lambda by 4, and another one 5 lambda by 4. that is we can write general formula. This become x is equal to twice p minus 1, twice p minus 1 into lambda by 4, where p is equal to 1 comma 2 comma 3. We can put 1, we gets lambda by 4. We can put here 2, we gets 3 lambda by 4s. Okay, here x is equal to lambda by 4 comma 3 lambda by 4, next 5 lambda by 4. Then we can find here the distance between two successive nodes. The distance between two successive nodes, this become 3 lambda by 4 minus lambda by 4 is equal to 3 lambda minus lambda upon 4. This become twice lambda upon 4. Here 2 gets cancel, here remaining 2. Here distance between two successive node is lambda by 2. The distance between two successive node we consider is a lambda by 2. See this diagram. Here antinodes, nodes, antinodes, nodes. We find distance between two successive node. The distance between two successive node, this is a lambda by 2. This is a first condition. And second one we consider here condition for antinodes. The point of the medium which vibrate with maximum amplitude are called as antinodes. What do you mean by antinodes? The point of the medium which vibrate with maximum amplitude are called antinodes. Here antinodes are the point of maximum displacement, that is we can discuss a is equal to plus minus twice a. Then according to this formula, twice a is equal to cos 2 pi x upon lambda is equal to plus minus twice a. Here twice a gets cancelled, remaining what? Cos 2 pi x upon lambda is equal to plus minus 1. Then we can find what is the value of 2 pi x upon lambda. Then we get plus minus 1. Here we can write this 2 pi x upon lambda is equal to 0 comma pi comma 2 pi comma 3 pi. We can put here 2 pi x is equal to 0, then cos 0 is equal to plus 1. Then we can put off 2 pi x upon 2 pi x upon lambda is equal to pi, then cos pi is equal to minus 1. In this way we get this value, and then calculate x is equal to 0, next lambda by 2, next lambda, and next one 3 lambda by 2. That is general formula. We can write this x is equal to lambda p upon 2, where p is equal to 0, 1, 2, 3 up to dot dot. We can put 0 into p upon this, we get 0 here. Next we put 1 into p, p is equal to 1, then lambda by 2, x is equal to lambda by 2, then put up 2 gets cancelled, remaining what? X is equal to lambda. Okay, then find distance. Then find distance between two successive antinodes, lambda by 2 minus 0. Okay, this become lambda by 2, and next one lambda minus lambda by 2, 1 lambda and half lambda, this become lambda by 2. See this diagram. Here two antinodes, here antinodes, here antinodes, take distance, this become lambda by 2. The distance between two successive antinode is lambda by 2. And another one we can find nodes and antinodes are formed alternately, therefore the distance between node and adjacent antinode is a lambda by 4. Okay, the distance between nodes and adjacent antinode is lambda by 4. See here is a antinodes, here it is nodes, then distance become adjacent antinodes, and distance between nodes and adjacent antinode, this become lambda by 4. Lambda by 4. Okay, basically some question asked on this topic show that distance between two successive node or antinode is lambda by 2, and the distance between nodes and adjacent antinode is lambda by 4. Then we discuss another topic. Next one is a characteristic of stationary wave. First characteristic, stationary wave are produced due to superposition of two identical wave, either transverse or longitudinal wave traveling through a medium along the same path in a opposite direction. This is the first characteristic. Second one, if two identical transverse progressive wave superimpose or interfere, the resultant wave is a transverse stationary wave. Okay, two identical transverse progressive wave can interfere, then the resultant waves is a transverse stationary wave. Here when transverse stationary wave is produced on the string, some point on the string are motionless. These points which do not move are called as a nodes. Next one, some point on the string oscillate with greatest amplitude, they are called as antinodes. And next one, the point between the nodes and antinodes vibrate with value of amplitude between 0 and A, 0 and capital E. And then third characteristic of stationary wave, if two identical longitudinal wave, longitudinal progressive wave superimpose or interfere, the resultant wave is a longitudinal stationary wave. For example, we consider here stationary sound wave produced in a pipe closed at one ends. Here same, the point at which the amplitude of the particle of the medium is minimum, we consider 0, are called as nodes, and the point at which the amplitude of the particle of medium is maximum are called as antinodes. The point between nodes and antinode vibrate with value of amplitudes between 0 to A. And fourth characteristic, the distance between two successive node is lambda by 2. The distance between two successive nodes is lambda by 2, and the distance between two successive antinode or consecutive antinode is lambda by 2. See this diagram. See this diagram. In this diagram, the distance between two successive antinode, this become lambda by 2. Another one, nodes and antinodes are produced alternately. These in stationary wave, nodes and antinodes are processed alternately. The distance between, next one, the distance between nodes and adjacent antinode is lambda by 4. Okay. Number 8, the amplitude of vibration. The amplitude of vibration varies periodically in space. All points vibrate with the same frequency. uh, Vibrate, all the particle vibrate with same frequency. Next one, though all particle except those at the nodes possess energy, there is a no propagation of the energy. The wave is localized and its velocity is 0, therefore it is called as stationary wave. Next one, all the particle between adjacent nodes Consider here in one loop vibrating phase, there is no progressive change of phase from one particle to the another particle. And next one, all the particle in same loop are in the same phase of a oscillation which reverse for the adjacent loop. And last property, last characteristic of a stationary wave, stationary wave cannot propagate through the medium, so there is no transfer of energy, no transfer of energy. In this way we discuss what is a characteristic of a stationary wave. Some question asked on this topic, state the characteristic of stationary wave. And last point we can discuss here, what is the distinguish between progressive wave and stationary wave. uh, First point we can discuss here, in progressive wave they always travel in the forward direction away from the source, they always travel in the forward direction away from the source. And a stationary wave they remain stationary. Next point, they transfer energy through the medium. In progressive wave, uh, there is transfer energy through the medium, and in a stationary wave they do not transfer energy through the mediums. Third one, all particles vibrate with the same amplitudes, and here all particles vibrate with different amplitudes. Amplitude is same, and amplitude here is difference. All particles of the medium are vibrating in progressive wave. All particles of the medium are vibrating, and in a stationary wave particle at nodes do not vibrate at all. Do not In a stationary wave particle at nodes do not vibrate at all. And last one, every particle vibrates, every particle vibrate with a different phase. Every particle vibrate in progressive wave, every particle vibrate with different phase. In a stationary wave all the particle in one loop are same phase. And last one, they are produced, due to disturbance phase of adjacent here. They are produced due to disturbance created by source. And in a stationary wave they are produced due to interference of two identical simple harmonic progressive wave traveling in opposite direction. In this way we can distinguish between progressive wave and stationary wave. Some question asked on this topic, distinguish between progressive wave and stationary wave. Today we complete this topic, stationary wave. In this topic we can discuss firstly what is formation of stationary wave, then we can discuss what is the actual definition of stationary wave, and then we can derive equation of stationary wave on a stretch string. And then we discuss three condition for nodes, antinodes, antinodes. And last one we can discuss what is the characteristic of a stationary wave. Today we stop here.